Okay, hi and welcome to another installment of Math Basics with Mr. Besh. Today what we're going to do is deconstruct a 3D shape into its primary building blocks, which are vertices, edges, and faces. And then we're going to take a closer look at the edges, and through definition we are going to identify whether these segments are parallel, perpendicular, or skew. Now I wanted to use the most basic three-dimensional shape, and that is a cube. It's formed by taking 6 squares, putting one on the top, one on the bottom, one in the front, one in the back, one in the left, and one in the right. Now they're put together at corners, and these corners in a three-dimensional shape are referred to as vertices. They're basically a point. If I have one of them, it's called a vertex, and I have them all labeled by letters. So that my 8 vertices up here are A, B, C, D, E, F, G, and H. Now when I go from one vertex to another vertex, like from A to C, I form a line segment. That line segment is referred to as an edge. In this picture, there are 12 edges. There are 4 on the top, A to C, C to D, D to B, and B back to A. There are 4 on the bottom, and then there are 2 on the right and 2 on the left, which make 12. And when I take my edges and my vertices and put them together, what I end up creating is a face. The faces are the squares in my cube. When I travel all the way around and go from A to C, then from C to H, then from H to E, then from E back to A, I make a square, and that's referred to as a face. This cube has 6 faces: top, bottom, left, right, front, and back. Now, remember, all three-dimensional shapes have a different number of vertices, edges, and faces depending upon what they are. You just have to take the time to count them. Now, when we look at the edges, we got vocabulary terms that are associated with these. Now, lines, line segments, edges, for all intents and purposes in this lesson, we are going to consider them the same for right now. Obviously, lines and line segments are different. Lines can't be measured, line segments can, and line segments are edges when we get into three-dimensional shapes. But when we talk about them being parallel, edges that never intersect, that's key, because a lot of students, when you ask them what parallel are, they say they do not touch, and that's correct. But another key important part of that definition is that they're equal distance apart at every single point. And last but not least, they can be in different planes. They do not have to be in the same plane. And that's going to be something else that I explain in a little bit, exactly what is a plane. Perpendicular, the 2 key phrases are they have to be in the same plane, and that when they do cross, when they intersect, they make 90-degree angles. They make right angles. So to be perpendicular, you have to be in the same plane, and you have to intersect and make 90-degree angles. Remember, intersect means they cross. Lines cannot cross if they are in different planes. And last but not least, skew. 2 lines are considered skew if they are in different planes and they're not parallel. Okay? So the definition of skew is saying that if 2 lines are skew if they're in different planes and they're not parallel. Now what we're going to do is we're going to go back to our cube, and I'm going to refer from one specific edge to show all of my examples. And the edge I'm going to use is from vertex A to vertex B. So my edge is going to be AB. Okay? Now first I want to explain about planes. Planes are the flat surfaces that this edge is associated with. Every edge in a three-dimensional shape is associated with 2 planes. As you can take a look here, the planes that edge AB are associated with are first the top square, top face, from A to B to D to C, and then it's also associated with the side, the left side plane, A to B, F to E. Now, what we're going to do is we're going to use this model, and we're going to take our definitions and we're going to break them down one by one. Now, when I'm talking about line segment AB, they are parallel, and I go back to the definition, edges that never intersect and are equal distance apart at every point, and they can be in different planes. And my answers to this are the line segments or edges C to D, E to F, and last but not least, outside the planes G and H. And let me show you what this looks like so you get a better chance. What I have highlighted in red here are all my edges or line segments that are parallel to AB. Notice CD and AB are in the same plane on the top. Now when I say in the definition part that they have equal distance apart, what you do is you take a point on one of the line segments that corresponds with a point on another line segment. Like for instance, B on AB is exactly the same spot as D on CD. And the distance from A to D is exactly the same distance as it is from A to C. Two more corresponding points on two different lines. So because they have the same distance apart, and your number one ally with parallel is your eyes, take a look. AB and CD, they're identical. They're just on opposite sides. So they would be considered parallel. They satisfy the criteria. They are equal distance apart. They never cross, and they can be in different planes. Well, these ones are in the same plane. And the same thing goes for EF, except now you're going vertical rather than horizontal. And last but not least, you've got GH. Notice GH looks exactly like AB, but if you go back in the definition, they can be in different planes. Notice GH is not in the same plane as BA, either one of them, but yet if I measured the distance from their corresponding endpoints from B to G, it would be exactly the same distance as if it went from A to H. So that is why they are also parallel. So my parallel line segments that I have up here in this shape, parallel to AB, are CD, EF, and HG. Now, perpendicular. Remember, they have to be in the same plane and they have to intersect at 90 degrees. Again, we are going to take a look at line segment AB. And the line segments that are perpendicular to AB are AC, BD, BF, and AE. They make gigantic L's, pluses, crosses, okay, to make these 90 degrees. If you take a good look from A to B, the blue lines up here highlight which are perpendicular to AB, all right, that make 90-degree angles. A to B and then B to D, they form a 90-degree angle. Notice perpendicular lines touch AB, okay? And not just do they touch, they form 90-degree angles, all right? As you can see, there are four of them. There are four of them. A to E, I got B to F, I got B to D, and then I got A to C. Another thing that I wanted to bring about is that if I say I have B to D, that is exactly the same thing as saying from D to B. The distance from B to D, or edge or line segment BD, is the same thing as saying line segment or edge DB. Back and forward, that doesn't matter. So this is what it means to be perpendicular. Now notice, they're in the same plane. They have to be in the same plane. AC and BD are in the same plane AB is in, which is the top plane. And then AE and BF are in the same plane as AB, which is the left square or left plane. Okay? Last but not least, you have skew. First off, skew, they have to be in totally different planes, and they can't be parallel. They can't be parallel. And to AB, there are only four that satisfy this criteria: D to G, C to H, F to G, and E to H. When I take a look at the picture, notice I kept my parallel lines to AB up here highlighted in red, except I got one more here I got to put. I just saw that right now. Just caught this one. Oops. From G to H. So from A to B, C to D, G to H, F to E, all of these are parallel. And then what I have is I have my perpendiculars, B to D, A to C, A to E, and B to F. Now, what's highlighted in green, these are what's left. D to G, C to H, F to G, and E to H. Notice they are not in the same planes as AB, and they are not considered parallel to AB. So as a result, they are considered to be skew. Now just take a look and digest the figure, because everything is all lumped up into this one right now. Reds are parallel, blues are perpendicular, and the greens are skew to line segment AB. Now remember, this was all in perspective to line segment AB. If I would have chose another line segment here, my answers would have all varied. Things would have changed, but they would have had exactly the same principles. So this, ladies and gentlemen, is deconstructing a 3D shape into vertices, edges, and faces, and identifying whether they're parallel, perpendicular, or skew. I hope you found this both helpful and informative.